In this video, we're going to start topic 5.1, solving systems of equations by substitution and elimination. So we're going to answer the question, how do I solve a linear system of equations? And our I2, I can statements are I can solve a system of equations by the substitution method, and I can solve a system of equations by the elimination method. We are also going to examine the graphing method. All of these things you have seen before. Let's take a look at this first one here. So a solution of a systems of equations. A solution to a systems of equations is an ordered pair that gives the true result when plugged into both equations. If one equation is a multiple of another, for example, y equals x plus 1 and 3y equals 3x plus 3, then there are infinitely many solutions. It is possible for the system to have no solution. For example, you solve to get where you get x squared minus x plus 1 equals 0, which has no real solutions. And if you look below here, so there's some classifications. A consistent system has graphs that intersect, like in the picture. There's one point of intersection, that's the solution, and there's exactly one solution to the system. In a dependent system, which we would call this one consistent and independent, and this one we technically call consistent and dependent. So basically it looks like one line because the graphs are identical. They're laying on top of each other. There's infinitely many points of intersection because there are infinite solutions. In this third type of system, it's what we call an inconsistent system. And in this system, we know the graphs are parallel. There's no points of intersection and there are no solutions. So to solve by graphing, we graph each line. I don't know what happened there, sorry. We graph each line. The point where the line intersects is the solution. So we're going to practice, we remind ourselves how to graph a line here. So this first one, remember to graph a line, I got to solve for y, so I'm going to subtract the x from the other side. So you get y equals negative x plus 4. To graph that line, I start with my y-intercept at 4. 1, 2, 3, 4. And I'm going to graph the slope, which would be down 1 over 1. And I choose to do a lot of dots because I want to make sure that my solution is correct. Okay, and then I'm going to look at my other line. I am going to subtract the x, so we get negative y equals negative x plus 2, and then I have to divide by negative 1. So you get y equals x minus 2. So my y-intercept on this one is negative 2. And I have a slope of up 1 over 1. Up 1 over 1. Something does not look like it went right. Down 2, up 1 over 1, up 1 over 1. Over 1. Oh, I counted up too many on this other line. So let me redo the blue line. So we have, we had to be up 4, 1, 2, 3, 4. And then we were down 1 over 1. And do you see where they just crossed right there? So this point right here is the solution, and I could read that point off the graph. That point is out 3, up 1.